In this video, we're continuing to look at mathematical problem solving in the theory of combinatorial games. We spent the last 3 videos looking at position analysis, but in this video we're going to look at a new technique. As a quick reminder, we're looking at games which satisfy certain special properties which make them easier to analyze. These properties are as follows. All games are for 2 players, there is no chance or randomness involved, both players have full information about the game at all times, and the game ends with a win for one of the players or a draw. These conditions mean that either one of the players has a winning strategy or both players can force the game to end in at least a draw. Position analysis was very good for finding winning strategies, although it could also be used for games which can be drawn. The strategy in this video works better for finding ways for players to force a draw, but can sometimes find winning strategies too. At the end of the last video, I asked you to think about the game of Museu Noughts and Crosses. This game works in the same way as regular Noughts and Crosses, but the first player to make 3 in a row loses. It is well known that playing optimally, you will always draw a game of normal Noughts and Crosses. And if you've tried the Museu version, you may well think that the same is true in this case. But what is the strategy? Looking at the board, you can see that it's symmetric, and in particular, with the exception of the central square, each square is either diagonally or orthogonally opposite another square. So you can pair up each of the squares except the central one. How can player 1 use this to force a draw? If they first play a nought in the central square, then player 2 must play in one of the paired squares. Thereafter, whatever player 2 does, player 1 plays in the paired square. Why does this guarantee a draw, or at least not a loss for player 1? Well, suppose that player 1 adopts this strategy and ends up losing somehow. Then they must have made 3 noughts in a row. But because of the way we paired up the squares, this cannot involve the nought in the central square. Moreover, it must be mirrored by 3 crosses on the other side of the board, and player 2 would have placed their final cross before player 1 placed their final nought, so player 2 would have already lost. We might reasonably expect that player 2 will not play to lose in this way, so the game will be drawn. So that's how player 1 forces a draw. How does player 2 force a draw? So long as player 1 plays the pairing strategy, player 2 just needs to avoid making themselves lose, which is easy. If player 1 departs from the pairing strategy at any point, then player 2 can adopt the pairing strategy themselves and force a draw in the same way. As you might have guessed, the technique that we're discussing in this video is called pairing. First, we want to work out all the possible moves which can be made. Note that this is not the same as the positions that we were looking at in previous videos. In Noughts and Crosses, for example, the positions are all possible configurations of noughts and crosses in the 3x3 grid, while the possible moves correspond to the 9 squares in the grid where a player might place their mark. Having identified the possible moves, we want to pair them up in some way, so that if one of the players always makes the move which is paired with the move that their opponent just played, then they can avoid losing. As we saw with Museu Noughts and Crosses, sometimes it's not possible to pair up every single move, if there's an odd number of moves, for example. So there may have to be slight variations on the basic strategy. I have 3 games for you to think about where pairing may be useful. 1D Noughts and Crosses. This game is played in a row of squares which extends infinitely in both directions. It's played just like normal Noughts and Crosses, and the first player to make 3 in a row wins. How can the players force a draw? In this game, a draw means that the game goes on forever with neither player winning. 5 in a row Noughts and Crosses. Going a step up, This variation of Noughts and Crosses is played on an infinite two-dimensional board, and the aim is to make 5 in a row, either horizontally or vertically, but not diagonally. Again, can either player force a draw? Jumping coin game. The third game is confined to a 7x7 board and begins with a coin placed on the central square. 2 players take it in turns to move the coin to anywhere else on the board. The only restriction is that on each turn the coin must be moved a greater distance than on the previous turn. The player who cannot move loses. Which player has the winning strategy? Quite a short video today, but the previous one was quite long. Thanks for watching. There will be one more video on game theory before we move on to a new topic. Don't forget to comment below with your ideas about how to find strategies for these 3 games, and subscribe to be notified for the next video.